Lesson 6-7. Trigonometric form of a complex number operations. Let's start off. So in the previous lesson we talked about complex numbers. So let's talk about operations of complex numbers. So starting with multiplication and division. To multiply these, we would have to go 2 times 3, 2 times negative 2i, 3i, and that would be negative 2i squared. I squared is negative 1, so that becomes a plus 2. 6 plus 2 is 8, and the i's would be negative I. So it would be 8 minus I. Turns out that there's an easier way if you have trig form. So if those are my two complex numbers in trig form, to multiply them, you multiply the r's and you add the angles. That's all you have to do. Multiply the r's and add the angles. And you have multiplied the trigonometric form of the complex numbers. Let's try division. Remember, for division, you have to multiply by the conjugate of the denominator. Alright, so I'll have 2 times 3 is 6, 2 times 2i, I times 3, I times 2i. The bottom, I have 3 times 3, 3 times 2i, negative 2i times 3, negative 2i times 2i would be negative 4i squared. I squareds are negative 1, so on the top looks like I have 6 and negative 2, and then 7i. On the bottom, I squared is negative 1, so it looks like I have 9 plus 4 is 13, and those cancel out, so I have 4 13s plus 7 over 13i. It's a little bit of a pain. There is an easier way. And if we have trig form, the complex numbers, you actually have to divide the r's and subtract the angles. You divide the r's and subtract the angles. So here are two complex numbers in trig form. Let's multiply them. So to multiply them, you multiply the r's and you add the angles. That would be 18 times cosine of, let's see, I need a common denominator, so it looks like it's 2 plus 1 would be 3 pi over 4. There you go. Easy peasy. How about division? For the division, you divide the r's and you subtract the angles. So that looks like it will be 1/2 cosine of 1 pi over 4 Look at that. Piece of cake. All right, exponents. All right, exponents is repeated multiplying. So it's this guy's theorem. I can't even pronounce his name. De Moivre's, something like that. He's puts together, well, it's multiplying. So, but it's the same thing. So we use the multiplying, and it end up doing an exponent to the r and multiplying the angle by the exponent. So if z is 1 plus I, find z to the fourth. Well, the first thing we'll have to do is get this into trig form. So to get it into trig form, the r is the square root of a squared plus b squared, or 1 squared plus 1 squared, square root of 2. So r is the square root of 2. Get the angle, use tangent. It's b over a. So when does tangent equal 1 on the unit circle? That happens twice, there at pi over 4, or here at 5 pi over 4. Since it's over 1 and up 1, it's pi over 4. So theta is pi over 4. So z is r cosine of the angle plus I sine of the angle. All right, so to the fourth power, be square root of 2 to the fourth power, cosine of 4 times pi over 4. It's I times sine of 4 times pi over 4. Multiply the angle by the exponent. All right, square root of 2 to the fourth, that'd be the same thing as square root of 2 squared, or 2 times 2, so it's 4. And when you multiply the angles, the 4's cancel out, so it'll be cosine pi plus I sine pi. That's way easier than going 1 plus I times 1 plus I times 1 plus I times 1 plus I. Before we jump to the next thing, let's think about this. X to the fourth minus 16. To solve it, you would probably say, oh, it's x to the fourth equals 16, and then you do a plus and minus fourth root, which would be plus and minus 2. But if I solve it by factoring, it's a difference of squares. It's x squared squared minus 4 squared. So it would be x squared minus 4, x squared plus 4. Well, this first thing is also a difference of squares. That's x minus 2, x plus 2. And then I take each of those equal to 0. And I get x is 2, x is negative 2. Look at that, it's that plus and minus 2. But I also get plus and minus 2i. So there are actually 4 answers. Negative 2, positive 2. Negative 2i, positive 2i. And we know we should get 4 answers because it's to the fourth power. So it turns out that there are 2 square roots, 3 cube roots, 4 fourth roots, 5 fifth roots, and so on of any number. So whatever root you are looking for, there are that many different roots. So if we have complex numbers, to find the nth root of a complex number, and this will actually give you all of them, not just the real answers, like the plus and minus 2. So it'll give you including the imaginary answers. So you do the nth root of the r, which gives you the real answer, but then the angles give you the imaginary parts. So the angles, theta plus 2 pi k over n. k starts at 0 and counts up. So if you're doing cube roots, it'd be 3. So you'd have 0, 1, and 2. If you're doing square roots, you just have 0 and 1. If you're doing fourth roots, you have 0, 1, 2, 3. So k starts at 0 and counts up to 1 less than whatever root you're looking for. And what's really cool, these are evenly spaced around a circle with a radius nth root of r. So let's think about these fourth roots of 16. So what we've done here, this original problem, is we found all the fourth roots of 16. Right there, fourth roots of 16. So they were 2. The fourth root of 16 is 2. But I also had negative 2. I had 2i and negative 2i. So notice it's a circle. Those points evenly spaced through the circle, and the radius is the nth root of r, fourth root of 16. They're all like that. It's pretty cool. If you do cube roots, you'll get them like here and there or something, spread out evenly. It's really cool. So let's find the cube roots of negative 6 plus 6i. All right, let's start by putting it into trig form. And we pretty much have to do it in trig form because there's no good way to do it in standard form. So r is a squared plus b squared. So that's the square root of 2 times 36, or 6 squared of 2. All right, our angle, tangent over angle, would be b over a, which is negative 1. So where does tangent equal negative 1 would be in quadrant 2 or quadrant 4. So we look and see where it's a negative 6 plus 1, so it's this one here. So our angle is 3 pi over 4. So z is 6 squared of 2 cosine of 3 pi over 4 plus I sine of 3 pi over 4. All right, let's find the roots. So we're looking for the nth root of r cosine of theta plus 2 pi k all over n plus I sine of the same thing. All right, so let's start off with k is 0. All right, my n here, I want the cube root, so n is 3. So I want the cube root of 6 squared of 2 cosine of, my angle is 3 pi over 4 plus 2 pi, k starts at 0, and n is 3. All right, so 2 times pi times 0 is 0. So I have 3/4 divided by 3 is 1/4. And let's go ahead and put these in our calculator and round them to 4 decimal places. So if I put it in my calculator, we distribute, I end up with 1.4422 plus 1.4422i. So that is my first root. Let's jump to the next one. K is 1. K is now 1. All right. To add the angles, we're going to need a common denominator. So this would be 3 pi over 4. 2 pi would be the same as 8 pi over 4. All right, so that would be 3 plus 8 is 11 pi over 4 divided by 3. Well, fourths divided by 3 is just twelfths, so that would be 11 pi over 12. And if I put that in the calculator, it becomes approximately negative 1.9701 plus 0.5279i. That's my second of the cube roots. Lastly, we do our third one. K is 2. This time, put a 2 for the K. We'll need a common denominator. So 2 pi times 2 is 4 pi. So if I put it over 4, so that would be 16 fourths. All right, so I have 3 pi over 4 plus 16 pi over 4 would be 19 pi over 4 over 3, which would be 19 pi over 12. If I run that through my calculator, that gives me 0.5279 plus minus 1.9701i. If we were to graph those, the first one, 1.4422, 1.4422 would be right there. Then I have negative 1.9 up 0.5, which is probably about there. And then over 0.5 down about 1.9 right there. And you can see those are evenly spaced around the circle. The radius of that circle would be the cube root of 6 squared root 2. Isn't that cool? That's all there is for today. Have a good day.